When you walk into a forest, what you see is the silence, this quiet kingdom of ancient, solitary giants, each one reaching for its own piece of the sky. But that's only half the story, because beneath your feet, there's another world entirely, a secret, humming network of immense complexity that we're only just beginning to understand.
It sounds like something out of a fantasy novel, right? But just imagine it for a second. What if trees could send warnings to each other? What if they could share food with their neighbors? Or even recognize their own children? What if the entire forest was having one continuous conversation?
Well, it turns out they can. And realizing how they do it completely changes how we see the natural world. To understand this, we have to look underground. All right, so to really get this, we need to start with the hardware, the physical infrastructure that makes all of this possible. Only this isn't made of fiber optics or silicon. This network is alive. This is mycelium, and it is mind-bogglingly vast. Under every single footstep you take in an old forest, there can be hundreds of miles of these impossibly fine fungal threads. It's not just in the soil. In many ways, it is the soil, a living biological fabric that literally weaves the entire forest together. So you've got this massive biological internet. But how does a tree actually log on? It uses a connection called mycorrhiza. You can think of it as the tree's own personal Ethernet port. It's the precise point where the fungus physically connects to the tree's roots, creating one of the most successful and important partnerships on Earth. And this is no free Wi-Fi service. It's a brilliant business deal that's been running for over 400 million years. You see, trees are basically nature's solar panels. They're incredible at turning sunlight into sugar, but they're not so good at mining the soil for minerals. Fungi, on the other hand, are master miners, but they can't make their own food, so they strike a deal. The tree trades sugar for nutrients. Honestly, plants were doing solar efficiency long before our engineers even got the memo. So, the hardware is in place, but this is where things get really interesting, because this network doesn't just move nutrients around like a plumbing system. It seems to move information. It acts like a true social network. And this shows us exactly how. In these incredible experiments, scientists watched as one plant was attacked by insects. Almost instantly, it sent out a chemical SOS through the network. A few minutes later, its neighbors, totally untouched by the threat, got the message and started producing their own defensive chemicals, making their leaves taste awful. They essentially got a warning text from their neighbor and armed themselves before the enemy even arrived. And this network isn't just a random web. Just like our internet, it has hubs, massive, critical nodes that are more connected than anything else. And the forest ecologist Suzanne Simard gave them a perfect name: mother trees. These huge, ancient trees are the central servers of the forest. Simard's research was groundbreaking. She used radioactive carbon tracers to actually watch as these mother trees sent their excess sugar through the network, funneling it directly to their own seedlings that were struggling for light on the forest floor. It's like a biological welfare system, where the elders of the community actively support the next generation, making the whole forest stronger. A cooperative network where trees warn each other of danger and nurture their young. It's a beautiful idea, but here's what most people don't realize. The science behind it isn't quite that simple. The story is perfect, almost a little too perfect. And in the world of science, when a story seems too good to be true, it's usually a signal to start asking some tougher questions. And here's the issue. The idea of the Wood Wide Web was just so compelling, so powerful, that it completely exploded in the public imagination. As this quote says, the story simply spread much faster than the hard scientific evidence could keep up. Now, let's be really clear here. This isn't about busting a myth. It's about refining it. Scientists are pointing out that while these networks are absolutely real, some of the more romantic ideas have been exaggerated. The popular story paints a picture of a cooperative utopia, but scientific scrutiny shows that competition is still a powerful force. These same networks can be used for sabotage, with some plants stealing resources or even spreading toxins. The debate isn't if the network exists, it's about the true balance between cooperation and conflict. So where does all this leave us? Is the magic gone? Absolutely not. If anything, the reality is far more complex, and because of that, it's far more fascinating than the simple story. Let's break down what we know for sure, because the foundation here is rock solid. Yes, these fungal networks exist. Yes, they physically connect individual trees. And yes, they are absolutely vital for that nutrient exchange that keeps the entire ecosystem alive. The potential for everything else, the warning signals, the resource sharing, is there. The key thing is that scientists are now in the thrilling phase of figuring out the precise rules of this hidden world. How it really works is the great mystery they're trying to solve right now. So, the forest isn't a simple fairy tale of selfless cooperation. It's a complex, dynamic system of alliances and rivalries, of trade and theft, an entire society with intricate rules we're just beginning to decipher. And that reality is so much more compelling. It really leaves you with one final thought. If this vast, ancient network has been operating right under our feet, completely invisible to us for all of human history, what other secret conversations are happening all around us, just waiting for us to finally learn how to listen?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.